evening for some colleagues around the world. As Fernando said, the session is devoted to the energy regulation and especially focusing on efficiency analysis, sometimes called also benchmarking in practice. And the people who have participated in the previous webinar, they remember we started with the introduction to the energy regulation, and the last Monday, we discussed also different types of regulation, starting from rate of return, cost of service regulation, and also then we went to the so-called incentive regulation, describing the caps and also different types of other regulatory methods like yardstick. And then we said in this session, actually, when we have been discussing the models, that there is one specific element which is the heart of the incentive regulation, and it is really the efficiency analysis, because regulators are using incentive regulation and they set usually ex ante the beginning of regulatory period the so-called efficiency increase factors, sometimes called in practice X factors, and these factors ideally they reflect the measured inefficiency of the regulated companies and accordingly also the derived efficiency increase targets for the specific company in the regulated business. And exactly that's the purpose of the presentation today, just to look a bit more at the specifics and to say exactly what is efficiency analysis, how it is used in practice, what are the models, what is the application of the efficiency assessment, and then to look also at international practice, some examples which have been observed in some of the European jurisdictions in the last probably I would say decade or even longer. Starting with the first point of this, or first topic in this presentation, introduction to efficiency analysis. Again, this is the figure, the graph, what I was using last time during the presentation, and we said when we're talking about incentive regulation, what is important to mention at the very beginning is that we are talking about a multi-annual regulation, so it means we have a regulatory period which is longer than 3, usually 4 to 5 years in practice. And then in addition, at the very beginning, we have also the so-called anticipated efficiency increase requirements, so usually using targets set by regulators. We said also that in the European jurisdictions, because of the energy policy of the European Union, we have unbundled the business, so we have a regulated area, transmission and distribution networks, in usually competitive areas, supply and generation, and we have this strict regulation in the nature of monopolies, in this case in the networks cases. We have some exemptions, but we're focusing more on the networks, and today we're discussing actually more or less focusing on this really regulated areas, electricity networks, and in this context again, the setting the efficiency targets and the efficiency analysis in general. And of course, if regulators want to set at the very beginning of the regulatory period this efficiency increase targets, so they have to do something before starting the regulatory period to measure the potential efficiency/inefficiency of the companies, and then to use this measurement, this estimation actually in this case, this estimation just to set these targets for the duration of the regulatory period. And this is how actually really regulation has been really working in the last years, or in the last decades, I would say. Regulators have checked, have constructed mathematical models. We'll come to this point in a minute in the presentation, and they have tried to measure the efficiency. They have derived inefficiency or efficiency scores, and then afterwards efficiency increase targets, and then they integrated these targets in the price control process. So in terms of really efficiency analysis, it's important not always to say how to estimate, how to measure the efficiency, but to say also how we're using really this efficiency results in the context of the price control. So this integration step is also very important because it exactly really shows how the regulated revenue will be set using also the analysis of the efficiency and also integrating these results in the process of setting the allowed revenues for the regulated businesses. Starting with the definition of efficiency, it is one kind of a simple way to say what is efficiency is usually to look at comparison of productivity between company 1 and company 2. And if we say talking about productivity, we can say that is one simple ratio in kind of simple case between the output and the input. If somebody is producing output in input, we can establish a ratio, for example, output divided by input, and then compare also this ratio with a second company, which is also producing output and uses also inputs to produce this output. In this case, we can see which is the company which is producing more, and then we can say probably this company is more efficient if they're using the same level of input. Of course, it sounds kind of simple. In practice, it's not so because we have several complications. Number one is we're using usually more than one input factor. We can use also in the production process, employees, fuel. For example, if we're measuring efficiency of generating companies, we can have also operational cost as a monetary measure, or we can have really total cost if we want to integrate not only the operating cost, but also the capital expenditures in the efficiency analysis. And of course, we have more than one output factors. If we look again in the distribution business, what will be their really output factors? They have to connect customers, they have to deliver electricity, they have to cover the peak load. Recently also when we see the increasing of the central generation, more embedded generation, they have to connect also embedded generation. And all this actually really functions more or less their output of the production process. So we have to incorporate them in the analysis. So in this case, we can say we have a multi-input, multi-output process. And the second actually very important point here in this analysis, in the comparison, is of course to ensure the comparability between the companies. It is seldom in the practice to see, just to observe that one company is exactly comparable to the others, because they usually exhibit differences in the operating environment. And in the analysis, what is done usually is the incorporation of additional factors. They call them sometimes in the regulatory terminology environmental factors. It is not related to the clean environment. In this case, it's just really factors which characterize the operating environment of the regulated companies. And they can be really several indicators. There could be also several indicators which can characterize this operating environment. In this case, just we listed a couple of them. In terms of network topology, could be a climate topography, could be terrain, also other variables, which all these actually areas of really of environmental operating environment, this somehow are considered and should be considered in order to eliminate differences in this operating environment, starting from the presumption that it is difficult to control from the company's point of view the operating environment. So they have to operate in this environment. That's why we have to consider also in the efficiency analysis the characteristics of this operating environment. So in general, we can say we try to measure really the ratio between outputs and inputs. We have to consider the multiple input and outputs in this process, and also we have to incorporate properly the factors which characterize the operating environment in order to ensure comparability of the companies and then adequately to measure their efficiency performance. There are several reasons why companies can be efficient or not so efficient. And what you can see in slide number 5, we just try to list several of them. And usually one actually of the sources which is obviously or actually often really referred to is the so-called technological progress or technological change. Sometimes you see also in literature the word frontier shift. It actually means that companies can improve because of new technologies, and this technology shift is coming for different reasons. So in this case, if we manage to improve the technologies, it means to have technology shift or new technologies, to integrate them, to implement them in the production process, we can expect some increase of efficiency. Also, it is possible to use better the existing technologies, which is called the efficiency change in this case, because of better managerial methods or better use of input factors, or using better structure of the processes, we can improve the efficiency. And in this case, either using less input to produce the same level of output, or using the same level of input but increasing the level of output. In this case, we're talking about so-called pure managerial technical efficiency, and it could be also another effect under this efficiency change, the so-called scale effects. Scale of production can have also an impact of efficiency on inefficiency. The company can get bigger, and because of the increasing scale, depending how really it works the company, we can have also positive effect or negative effect depending where we are really now and how we just really move to the next level of scale. So these scale effects, they can also bring efficiency changes, and it's called scale efficiency or scale inefficiency. So under this efficiency change, we can see really changes resulting from improvement of managerial efficiency, but also in some changes resulting from the changes in the scale of operation of the companies. We have also additional sources, so-called allocative efficiency. In this case, we can improve the efficiency through better use of input factors, so just really to produce in the production process, of better really selection of output factors just on the output side of the production process. And last but not least, we can have also changes in the operating environment. In this case, as already explained, if operating environment can impose different effects on the cost side, on the input side, but also on the output side. And in this case, that's why actually, therefore, the operating environment or changes in the operating environment can have also an implication, can also affect the efficiency performance of the companies. What you can see here, just what I just listed shortly on this slide number 5, are different reasons for the efficiency/inefficiency of the companies. And what is important, of course, is when we're just looking at the really performance, just to take into account all these factors and just try to measure the efficiency/inefficiency. Usually, from the regulatory perspective, what is going on in the companies is not so interesting because it's a matter of the management, but it's important also to look at the overall efficiency performance, and if possible and desirable, also to distinguish between different types of efficiency, especially, for example, scale efficiency and managerial efficiency. That's important, and also to take into account the role of the operating environment to ensure, as already said, the comparability between the companies in the investigated sample. In terms of methods, now we're moving to the next slide, number 6 on the agenda. I said at the beginning that we can have different types of methods just to measure the efficiency. Starting with one general slide, what you can see 5 steps. Now we are on slide number 7, and these slides show you just in 2 major groups how really the benchmark analysis is done in practice. We separate 2 big blocks, as already said. One is called model specification, and one is called model application. The specification is really starting first with the preparation, how to really calibrate, how to prepare, to configure the model. And we have here 3 steps in this case, just in this first group, model specification. The first one is actually obvious one, we need to have a technique, yeah, kind of let's say analysis technique, mathematical technique. I'll come to this point in a minute in the presentation. What you can see, we listed 5 possible techniques. Starting from the last one, which is called partial. It means partial because we're looking at specific factors only, the so-called usually unidimensional techniques or unidimensional ratio. We select some specific variables on the input side. We select also some specific variables on the output side, and just we create ratios which can indicate potential efficiency in some areas of the company's performance. And what you see actually the abbreviations, I'll just try to list them shortly now, starting again from number 4, which means corrected ordinary least square. Number 3 is ordinary least square. Number 2 is stochastic frontier. And number 1 is data envelopment analysis. I'll come in a minute just to this also different types of techniques. What is important now for this slide is to remember that we have different techniques which are used to measure the performance, these mathematical techniques, and they have also different properties in terms of nature and approach, but they are used more or less in regulatory practice. Step number two, on the model specification, it is choice of the model parameters. Once we have selected the technique, we have to look at so now just what is on the input side and on the output side of the model. So it means we have to select parameter for the inputs and the outputs. Could be 1, 2, 3, 4, could be more than actually that, and it depends on the structure of the sample and also on the nature of the analysis. It is important also to select the model orientation. What means that actually we have 2 types of orientation. One is to look at the input, just looking at the minimization of input, keeping the output constant, or just on the opposite, we can keep the input constant and just try to maximize the output. Usually what we see in the regulatory applications is just looking at the input, believing that it's really the most controllable area of the companies, and just trying to minimize the input, keeping the output as a kind of constant and given. And last but not least, it's important to think also the so-called returns to scale, that's number 2 in this block. And it means that we can integrate also the scale of operation of the company. It means how big is the company. In this case, also in the efficiency analysis, it is possible to integrate it. And the major presumption is to say, do we want to see constant return to scale? That's one option. So it means that if we're increasing the input, so we're getting proportional increase of the outputs of the company. So there is a proportional linear relationship. Or we can also incorporate in the efficiency analysis the so-called variable return to scales. And in this case, we don't have a linear relationship. We can have an increasing return to scale, which means that with increase of inputs, we get over proportional, so it means more than actually the change of the input increase of the outputs. Or we can have the so-called decreasing return to scale, which will be the opposite effect. We have under proportional increase of the output if we change in the input. This is an important parameter because in this way regulators can decide whether they want really just to investigate and also to challenge the companies in terms of scale of operation. So in this case, as already mentioned on the previous slides, when I was explaining the previous slides, we can distinguish between the managerial and scale efficiency / inefficiency. So with the selection of the scales or constant or variable, we can also incorporate these things, these thoughts actually in the analysis, and challenge the companies not only for managerial inefficiency, but also for scale effects. And then the last step in the model specification is related to the sample, the choice of data. It is related to the sample size and then the data collection process. The first usual dilemma is whether we have to use national or international data. if we have enough companies in the country which we want to really compare and also regulate, for example, distribution companies, usually the choice has been to use national sample, just because we have sufficient number of companies. If we have insufficient number of companies, sometimes we have observed that in the transmission business or in some small countries which don't have really many companies for distribution, it has been an effort also just to use international data, just to populate the sample or to use sufficient number of companies in order to increase the representativeness and robustness of the results. Of course, using international data creates additional challenges in terms of homogenization and also really using properly these inputs in the international efficiency analysis. We have to use kind of, let's say, comparison criteria using international data. That's also part of the exercise to select, and also data validation is obviously intuitive step here. So we have to look whether the data, what have been submitted, is okay. So it means that we don't have obvious mistakes or inconsistencies. And these checks have been done in the preparation process just to eliminate obvious mistakes, errors, or somewhere when actually really something appears to us implausible. So this data validation process is important to ensure consistency of the data set. And when we start running the models, then just to be able to rely on the results. Now we go to the next big block model application. That's step 4 and step 5. In this case, it's related to really calibrating the models with the data which has been collected and checked, then running the different specifications, and then also looking at the results. Looking at the results, it means incorporates also sensitivity analysis, checking also really for the robustness of the results if we change the specification of the model or the different input-output parameters or the scale assumptions in this case. And obviously, if we see some outliers which actually really distinguish strongly from the rest of the companies, we can also experiment and isolate them, rerun the models just with reduced number of companies, in this case kind of trying to check and to study the effect of these outliers and also to understand the impact resulting from their inclusion or exclusion. If we look actually what has been done in the real practice, especially in the European jurisdiction, you can see that we have several applications up to now. We have really already history. I'll come to this point in the last slide when explaining the practical real application of the models. We've seen also a lot of application in UK in the 90s using using deterministic regression in this case. We've seen 97 Norway started using data development analysis. Netherlands 2002, 2003 again using data development analysis in the incentive regulation of the distribution grids. Germany later, in the course of implementing incentive regulation, decided to use two techniques, one which is data development analysis, which is non-parametric model, and also using stochastic regressions just for cross-checking to support. So we can see different models, and also interesting, sometimes we see the application of the so-called reference network models. I'll come to this point also in a minute, in some countries, which is looking for comparison not between company and company in the real world, but between a company and a fictive company based on engineering model, so it means of ideal network. In this case, this network is providing the reference case to compare the operating performance of the investigated company. So we have kind of mix of techniques and also different examples from the international experience. It's difficult to say that we have a consensus among regulators what is the best technique actually. What we can say that we observed a lot of application of data development analysis and also sometimes more than one technique just for cross-checking purposes, like I mentioned, for example, the German case. Now, in terms of really specification or classification of the models, we can group them in two major groups. One is the so-called partial, I already mentioned this one, and we established a group which is called total methods, total models, which has several actually really components here. Starting with the first one, as already mentioned, this is usually these partial methods have been based on simple unidimensional ratios. As already said, these coefficients based on selected input factors, could be different number of employees, could be also operational cost, could be even labor cost, just components of the operating cost, and then just normalize again these input factors against some selected variables from the outputs, could be gigawatt hours distributed, could be network length, or other really variables on the output side of the production process. And they provide, as already said, coefficients which can be easily compared. It's very easy to use this technique mathematically because it is simple calculation, simple ratios. The usual critique has been here that they characterize only partially the process of the companies and not really completely. So they're just focusing on one specific area of the performance, but not really on the whole complexity and on the whole completeness of the real production process of the companies. That's why we see these methods used just kind of, let's say, supporting schemes, just indicatively in regulatory practice. The major focus is more on the total methods. And then you can see here we grouped under these total methods, we established 4 subgroups, which all of them are totals, but they have different nature and different properties in terms of mathematical application. We have the so-called index methods. That's usually the so-called total factor productivity. I'll come in a second to this one. We have a group which is called non-parametric, or sometimes linear programming. This is especially the data development analysis. And we have a second group which is called third group which is called parametric, sometimes econometric or statistical models. And here we have the deterministic and the stochastic really regressions, started with the ordinary least square, corrected ordinary least square of stochastic frontier. I mean, the classification parametric, non-parametric is related here just to the fact that in the case of econometric models, we're using parameter because we're establishing an explicit mathematical function between input and outputs in this case. So there is a mathematical function, we have parameters, and that's why the models are called parametric. And as opposed to the case of data development analysis, we're using optimization technique based on frontier gain. And then we're using kind of, let's say, really possible reduction, for example, the input factors of one investigated company to arrive at the frontier. So it means the possible efficiency, inefficiency is measured through this reduction or potential reduction of inputs. And in this case, we don't use any explicit mathematical function. The model is called that's why non-parametric. And the last group, which is number 4 in this case, engineering models. As already said, it is possible to establish or to use comparison which don't compare company with a company, but more company with a virtual network or virtual place, virtual company. And to establish this virtual place, virtual company or virtual network, it is possible to use engineering methods and just to create hypothetical, in this case, for example, network, which characterizes well the operating environment of specific companies, to value really what is the cost level of this company in order to provide, for example, specific output with specific criteria for quality, and then to compare also the cost of this virtual company, virtual place, with the investigated company. That will be this approach. Of course, there are many critical points to this group, but it's important to mention this one in the classification, because in this way we arrive at kind of, let's say, we achieve completeness of the classification, and we have all the groups: index, parametric, non-parametric, and engineering techniques. As already said, you can see here one example of the first group, which is the partial models. And as already said, it is just simple ratio between selected parameters, gigawatt hours, for example, per employee, operational cost per gigawatt hours, operational cost per employee, or other. It is just a simple ratio which can provide an indication indication whether a company compared to the other company is performing well or not. As already said, the major critical point is too simple. It does not really consider well the operating environment, number two, and number three, it does not consider also the interdependencies of different parameters within the companies, the so-called substitution effect between different cost positions within the company process. And you can see one additional block, which is not productivity, but financial indicators on the right side on slide number 10. And this is actually used more or less to cross-check or to check really top-down if the regulated revenue can provide really some reasonable performance. It is not per se productivity ratios, they're more financial ratios which are used to cross-check again for top-down checks. And these ratios, they're classical, really they're coming from the classical corporate finance or from financial analysis. You can see ratios related to capital structure, debt to equity, return on investment on the total capital employed in the companies. They usually supporting, they do not indicate really the nature of the performance of the companies. They indicate whether the regulated company with this level of allowed revenue will be performing well in terms of, let's say, financial performance. Moving ahead now to a classification, I mentioned index models, and actually they are more or less based on the so-called total factor productivity. Sometimes you see here also even within this group also partial ratios, so-called partial factor productivity. This will be actually more really ratios belonging to the first group, to the partial, to the unidimensional models. Talking about this index method, the major logic in this case is that we are comparing really indexes in terms of output divided by input over time and looking for development of this ratio. If we're using, for example, company index, we'll see how really this index output divided by input is changing over time and can also derive some conclusions about the change of the productivity of the company over time. It is possible to use the index also for the industry in general. It is possible also to really incorporate this index methods also within DEA. So it will be the so-called Malmquist-DEA technique, which will really just distinguish between the overall productivity improvement of a company in the so-called catch-up. It means the relative efficiency performance improvement compared to the other companies in the sample. The second group, deterministic and stochastic parametric models, that this regression, the statistical models, and the DEA usually are used in the context of the so-called frontier approaches. It means that we are looking at the company which is best performing, and in this case, every other company is compared with the best performing company or companies in the sample. And this difference in terms of individual performance versus best performance will indicate the possible inefficiency of the company. So to establish this frontier, as already said, we can use either non-parametric or parametric technique. And now in the next slide, you can see a bit more really just explanation of these two models. Starting with the so-called parametric models, you can see here on one simple diagram, input X on the vertical and output Y on the horizontal axis. Then you can see several companies plotted on this diagram, and you can see the blue line, in this case called ordinary least square, or S line, which is crossing just the dotted points. And this line is a mathematical line. It's actually a result of simple regression analysis. It is a result of optimization process. So it means it's the line which is really in the best way approximate really the population of points. What means this actually is that really the sum of the square differences between the plotted points and the line is minimized. And you can see that this line, the blue line, is per definition is the average performance, because you can see also points on both sides of the line, on the south and north side really of the line. So we have some companies which are better performing, which are on the north side, and some companies which are on the south side. sorry, on the south side, and we can see some companies which are on the north side, they perform not so well. So in this case, you can see some companies better than the average performance and some worse. And that's why the motivation, especially for regulators, to really shift the line, and this actually is a horizontal shift of the line towards to the red line, which is called now corrected ordinary least square. So in this case, we're just shifting the line, the oil-less line. We create a new line, which is called corrected ordinary least square. And this line is really, the difference is just the largest residual element in the regression. So we are shifting the line to the best performer. You can see now that there is no company which is on the south side, so on the real downside of the line. This company, this line, the red line, is obviously the best performing. The frontier, the companies which align on this line will be the best performing companies, and every single other company in the sample should improve. So it means its first definition classified is not so efficient as the best company. And now there is one green line, which here is a big simplification. It's a so-called stochastic regression analysis, stochastic frontier. In this case, we are separating in statistical terms the so-called disturbance term, so the statistical error in two components. One is the inefficiency/efficiency, and the other one is really the stochastic noise. In this case, the idea is really just try to isolate the stochastic error and just, let's say, to measure the pure efficiency/inefficiency of the companies in the sample. Moving now on the right side of the slide, you can see the so-called data envelopment analysis. What you can see is one configuration which is input based. We have a company which has two inputs, x1, x2, and producing one output, in this case y. And then what you can see is really plotting the companies in one diagram, just with 2 dimensions, with the normalized input factors x1 and x2. And you can see what is called also in the theory, but also in practice, it is piecewise discrete convex frontier. So this line, which is A, B, C, D, E, you can see this line is created artificially. It's a frontier line. And now we can compare this frontier line, which is established based on the company's performance in the sample, with the investigated company, for example, company E. And you can see that E is a bit far from the frontier line. So obviously in this configuration, in this example, E can improve its performance, the company E, and this improvement is possible, for example, in this configuration with the so-called radial shrinking of the input factors. So company E can go down to the origin of the really system and just cross frontier at the point E prime. So this E prime, actually this really distance, is the inefficiency and the possible, obviously, efficiency improvement of the company E, which is compared in this case, in this configuration, with the frontier presented on the diagram. Here there are several options. I don't discuss them. We can have also not only this radial really shrink, or the shrinking of the input factors could be also different. We can have also different specification of the frontier if we're using the so-called variable return to scale. But the major logic is this one. We're just trying to create a case for each company in the investigated sample to check, to measure the distance to the frontier, to define first the frontier cross, to measure the distance to the frontier, and then to measure the possible improvement via this reduction of the input factors, looking at the so-called peer company, E prime in this case, and just to indicate the possible efficiency improvement of the investigated company. We discussed about the models. Now we have to say something about the application of the results, because as already said at the beginning of the presentation, one point here is to measure the efficiency. That's important. But second step, exactly so important, is to use the results. And that again is called application of efficiency results. And then when talking about the efficiency of the application, we have now at least 2 questions here to solve, to respond. You can see on this slide on the left side is the efficiency measurement, what we discussed and described now. And now you can see the so-called allowed revenue tariffs, just what's on the right side, the interface. On the right side of the interface, you see these two steps which are important for the application of the results. And we split them actually in conversion and integration, in kind of, let's say, two sub-steps. The first one is related really just to several small, but I would say important decisions. What are these decisions? If, for example, we measure that some company or estimate that some company is inefficient and should increase the efficiency, or it means to eliminate the inefficiency, we have to decide really for which time. Immediately, tomorrow, for 1 year, 2 years, 3 years, 5 years, or probably 10 years. Number one, the question. Number two is with which profile do we want to have kind of linear reduction of the efficiency, of the inefficiency over 5 years, or want to have non-linear reduction, for example. That's also a possibility. For example, stronger reduction in the first year and not so strong in the last, for example, the next 3 to 4 years. And then we have also the so-called inefficiency caps or efficiency bands. So this is related to so-called mitigation measures, and they have been widely used in practice. What does it mean, actually? It means that because of the incompleteness of the efficiency analysis, probably because of mathematical properties of the models, because of the data, because of the comparability issues, several regulators have been using these mitigation measures. It means they either cap efficiency increase, one possibility. It has been used, for example, in Norway, 97 efficiency bands with caps not more than 3% per company efficiency increase. Or it could be also, other option is to floor the efficiency scores. So it means to be impossible to be less efficient than a predetermined threshold. For example, in Germany, it has been used in the first price control period, efficiency floor of 60%. So it means the companies cannot be less efficient than 60%. So it's another way to mitigate the effect of the results, to make them more affordable, probably, and more acceptable for the company. And apart from the conversion, we have also the next step, which is called integration. And it's again very important point, is now when we have really established the efficiency increase targets, for example, 5% for one company, how to use it, on which base to apply it in operational costs, only operational controllable cost. Total controllable cost, it means integrating also capital cost, for example, depreciation in return, the price control. If we are applying just the company's results on the operating cost, what shall we do with the capital expenditures? Another important question. How to establish revenue requirements over time under the aspects of the integration of efficiency scores? And do we use kind of, let's say, really general regulatory formula? And if yes, how is really this efficiency/inefficiency or efficiency target integrated in the revenue or cap or the price cap formulas of the regulator? And in simple terms now, again, going back to these topics, to the important questions, you can see, for example, 5 companies which have been analyzed for efficiency performance. And let's assume this example on slide number 15 now. We have one company which is called C. This company is very efficient, 100% efficient. And we have also several other companies which didn't exhibit this efficiency level, so they have been classified as less efficient. For example, company A, B, company D, or company E, each of them is not so efficient as company C. And if we assume, for example, that company A is, let's say, assume 70% efficient, so it means 30% inefficient, so we have to look now what to do with this efficiency results. And as already said, it is important here to consider what is the time to eliminate this inefficiency. 30% inefficiency can be eliminated for 1 year, very heavy requirements, 30%, or over 10 years, 3% per year in linear terms. It can be eliminated in 2 stages, for example, 10% for 1 year, or smaller targets just for the next year, or it could be together, just gradual reduction with constant annual targets. And we can say that also, as already mentioned, that we can introduce, for example, cap on the efficiency targets or floor on the efficiency position. And in this case, for example, company D, which is probably in this case 50% efficient only, we can say even in this case, company D should get 70% efficiency target. So that's again part of these mitigation measures. So it's important always to remember that, I mean, when we have finished the efficiency analysis, we have to look also how to use the data, how to use the results, and how to integrate them in terms of conversion and also this integration in the price control process. And there is also one point which is important to mention. Sometimes in regulation we can also distinguish between two types really of X factors. One application of X factors is really just setting them equal to the efficiency increase target, which means we have started from one position and the X factor is the required efficiency increase, for example cost reduction, but they can be set in more complex way. It means just they can use not only or cannot take not only the role of efficiency increase, efficiency targets, but also of revenue profiling. In this case, we can also look at the analysis of efficiency, inefficiency, and then at the end we can set X factors. In this case, the X factors can be used to profile the revenue allowed, starting from one position and going to another one, which is perceived by the regulator as the most efficient position. So depends on the price control, as already said, the X factor can have a direct application, so it means equal to efficiency increase, target set by the regulator, or they can be a bit more indirectly applied, in this case, kind of integrating not only the efficiency increase function, but also the revenue profiling function. So it means showing the way to go from one level of revenue to the most efficient a couple of years later. But as already said, actually having financial profiling function. And this slide number 16 is again, that's what it described. It is the form of the conversion. You can see the blue line, it is a proportional increase of efficiency, or in this case, proportional decrease of cost over 5 years, for example. And you can see also the green line, when we have actually two-step approach. The first one is to reduce a bit stronger in the first year, and that's just to go gradually for the rest of the regulatory period. Interesting, it's possible also, for example, in Germany, to use really longer period, so it means period which is longer than the duration of the regulatory period, to eliminate the inefficiencies. For example, in Germany, the first price control period has been set at 5 years, but the regulator decided to use the time period to eliminate inefficiency equal to 10 years. So it means for the first 5 years, which actually is the duration of the price control period, companies have been really asked to eliminate only part of their inefficiency, because the efficiency elimination or inefficiency elimination period was longer than the price control period. Last slide, what is the situation on the international front, or actually in Europe? As already said in the previous, on the previous slides, we have observed several types of techniques also in several countries, and all the regulators which have been introducing or introduced in the past incentive regulation have been using kind of techniques also for efficiency analysis. Usually you can see the dominance of the data and development analysis used in the Netherlands, Germany, Austria, Netherlands, Norway, traditionally from 97, as already said. You can see also the parametric models with different specification codes and O's, but also stochastic frontier used in different countries. And you can see also the combination, what I mentioned, for example, Germany, Austria, using two types of models, one parametric, one non-parametric. Germany went even a step further. They've been using, in the first price control period, two types of models and two types of specification of the inputs. So just created kind of matrix which was with 4 really model runs, and then using the best of for the companies from these 4 model runs. two techniques and two input specifications. Important to say also here is that several countries like Germany, Austria, Norway traditionally have tried and actually have used benchmarking not only on operational cost but also on the total cost. In this case, they incorporated the capital cost in the model. So it means depreciation and return as a result of the capital expenditures in regulatory terms have been incorporated in the models. And of course, all the associated difficulties have been tackled in different way in the countries. Especially in Germany, we've seen all sort of discussion in the introduction of incentive regulation and the decision to use this on the total cost. A lot of discussion how to really measure the capital cost for benchmarking purposes, for efficiency analysis purposes. And here also two major topics have been really just discussed. One is really the differences in the age of the assets, and number two, differences also of the depreciation profiles. So if you want to say just kind of in general terms what has been observed in the countries which have used benchmarking analysis on total cost, then just try in some or another way to standardize the capital structure. So that is more or less the situation in Europe. Just to summarize what we said in this one, we have different benchmarking techniques. Incentive regulation requires ex-ante assessment of the efficiency of the companies for the purposes of setting efficiency increase targets. Regulators have been using widely benchmarking analysis using different mathematical techniques. We have the dominance of data development analysis, but we've seen the last years also increasingly usage of two techniques, parametric and non-parametric, and usually the results are not directly mechanically is used in the price control process. We have seen also different schemes how to convert and how to integrate the efficiency results in the price control process. Many thanks.
Great, thank you very much, Konstantin, for this comprehensive presentation. So now let's go for the questions and answers session. And for the time being, there is so much feedback on the questions. It was quite extensive, a quite in-depth explanation. So we would invite now audience to submit their questions if you have any doubts, any comments on today's explanations on the efficiency measurements. So let's give a few moments. Thank you. If you want to submit your questions, please use the Q&A pod, which is on the top in the middle of the screen. Thank you very much. Okay, so it seems to be no further questions. So on my side, I would simply ask to which extent this efficiency measurement and monitoring is applied. You have shown slides with relevant amount of distribution companies and transmission companies being monitored on this basis. Can you comment on the degree of application of this? Is that something always applied? Is there any regions where such efficiency measurements could be improved? Thank you.
In terms of application, Fernando, yes, they've been applied widely. You've seen also the results in the European Union. Of course, if you compare within the countries in the European Union, you can see different degree of also of application. I think also in terms of knowledge and also in terms of really experience of the regulators. I would say the driver of application is not always the incentive regulation per se. That's of course one driver, because we have to set kind of efficiency increase factors, but also it's the data, just to have really robust data. It has been also in several countries also the fact whether they have enough national comparators, and you can see big differences. For example, I mean, look at, for example, Germany or Scandinavian countries. We have several distributors, yeah. And look, for example, countries like Slovenia or other, they have, for example, only 5 or even less than 5. Romania, for example, has 8 on the eastern part, yeah. So actually, you can see that there is of course, the decision to use this benchmarking in terms of national data depends on the number of comparators, and that has been a second, really just a motivation to apply, just to go for this or not immediately. Um, in terms of issues, obviously there are many. Yeah, I think usually the issues have been related to the data quality. Number one, just to get the robust data quality. Number two is, of course, probably the major point I would say is really just whether we have enough really if we have ensured in the process of model specification the comparability of the companies, and in this case, if we have done that, can we really just trust the result? Yeah. So that's a major point actually where difficulties have been really observed in anyone in any of the European countries. And then that's why what I mentioned in the presentation also is this mitigation measures. Usually the application step is extremely important, because in this case, once we have measured the efficiency, inefficiency, then we are going for the next step, how to apply it. And as already explained, we have seen several countries using different really supplementary schemes to ensure, I mean, acceptance and affordability of the results.
Okay, good, thank you. Meanwhile, we received a question from Eugenia. So, under what circumstances can one use combination of techniques, and what would be the time frame for each of the techniques? Thank you.
Yeah, in terms of time frame, usually depends how just the question is now to understand this one. I mean, in terms of data, the data, if we just say how to use the benchmark, and the data is usually cross-sectional, could be also panel data. So it means we are collecting the data, and then the time frame actually is first we have the data. For example, if it's a cross-sectional, it's just 1 year data. And then once we have done the analysis, we're using the results for the next price control period. For example, could be 3 or 5 years, depends on the country. And that's one. In terms of combination, I mean, the simple actually point has been just to combine the techniques is, let's say, to cross-check the results and to check really to ensure so far it's possible the robustness of the results. That has been the major motivation. And that's actually why we've seen some countries which actually using really two techniques, parametric, non-parametric, just to measure efficiency. In that I just would say here to this point, yeah. In terms of time frame, if you just refer to the point whether one technique is kind of, let's say, appropriate at one time point to another, that's probably, you can argue what exactly is, for example, in terms of complexity. Stochastic frontier is more complex. Data and development analysis probably is less, kind of, let's say, it's less complex, but also again requires a lot of understanding. And of course, I mean, the data and the number of companies, they're very important also in both cases. Yeah, we have to have sufficient data, reliable data, and sufficient number of companies. Otherwise, if we have not really sufficient number of companies or wrong data, or so kind of not robust data inputs, then we can have serious issues with the results.
Okay, good. Thank you very much, Konstantin. So I believe we are close to the end of today's session. Let me just forward another comment. So from the same person, and how long would it take to conduct the exercise?
Oh yeah, it is an easy one actually to conduct. I think if you have the model specified and actually data collected. I think the major point here is really to ensure the data availability. That's number one, and it's a process because to have really homogeneous data, well specified, really robust check, that it takes time to establish the templates, to iterate with the industry, to explain the process, to collect the data, and just to agree on the specification. That could be really a long process. We're talking about efficiency measurements, and it's a very sensitive topic to the management of the companies. That's normal. And then afterwards, of course, when we see the results, then again, it's actually really that again to get the confidence of the industry in the results and to decide on the application could be also a next step. In terms of mechanical really application, that's not difficult, but actually then what is difficult is really to collect the data, to specify the models, and it can take months. We've seen also it could be years, yeah, 1.5 years even could be also, yeah. Depends how big is the industry, what is the situation with the data inputs, what is really the strategy of the regulator to use the data and the results, yeah. That could be also really a process which is could be a long process in terms of consultation, yeah. I assume that actually the knowledge is there. Of course, we've seen some other regulators in countries where the knowledge is not there, then it's getting longer because they have to first understand the process, to learn about the mathematical techniques and also to see what has been done in other countries, just to get confident and then to decide to go to the industry for their own application. So it could be really a long process, yeah.
Okay, great, thank you. So we arrived to the end of today's session. Thank you very much to our audience for being there. Thank you very much as well, Konstantin, for these clear and comprehensive explanations. And well, I say you goodbye until next Monday with the third session. And Konstantin, I give you the floor to close today's session.
Many thanks, Fernando. Also, on my side, just to say really thanks to all the participants, and I hope that we have just contributed to your understanding and also on the application of this efficiency analysis. And then if any questions appear, just don't hesitate to contact Fernando and myself. We can also respond to them in written way afterwards, and really looking forward for the next section next Monday about the capital expenditures.
Thank you. Goodbye.